Hi everyone, my name is Anika Mukherjee and I'm an SRE at Pinterest. And today I'm going to be talking about how Pinterest adopted a metric called user uptime in practice, which is based off a paper by Google called Meaningful Availability. So a little bit about me. Like I said, my name's Anika and I'm an SRE at Pinterest. I've been there for almost 3 years now. Before I was an SRE, I had a background in iOS development and in performance, particularly Python API performance. And now as an SRE, I'm responsible for the reliability of our pinner-facing systems. So I work really closely with our core API, or core web, and our traffic infrastructure teams. So availability metrics and choosing the right ones to measure is really important for SRE. After all, we are site reliability engineers. So understanding exactly what we're measuring the reliability of and how we measure it is pretty critical to get right. And there are different availability metrics that are better for different use cases. So asking who is the audience and how we intend to use this metric is a really important process when identifying what metrics we want to track. For example, an availability metric that's used for an SLI for an air budget is probably going to be very different from metrics that we use to track success of projects, which is also going to be very different from availability metrics that we report to leadership or that we're using during incidents. And the latter two is actually what Pinterest was trying to work towards. We wanted a better availability metric to report to leadership and that we could leverage during incidents that better helped us communicate what the user impact of certain situations were. Success rate is a really common availability metric, and it's what we were using previously. So a little bit about success rate. Success rate is really simple. A lot of people use it. It's very easy to reason about and comprehend. Simply put, it's the percentage of successful requests. So it's a count-based metric, meaning we count the number of successful requests and divide by the total number of requests to the system, and or responses, really. And so success rate is really useful for measuring health from the perspective of the server, meaning that success rate helps us identify what the server thinks is responding to the user to some extent, or sort of like what number of requests is the server responding to successfully. However, this isn't great for understanding user experience for a few reasons. One of which is that since success rate is a count-based metric, it indexes on overactive users, meaning that if I make an order of magnitude more requests than someone else, success rate is going to be much more heavily weighted towards my experience than that other person's experience. Also, in success rate, all requests are treated equally, but that's not really the case for user experience. For example, a user is a lot more likely to be unhappy with Pinterest if they get no search results, if their search page is just empty, versus if they don't get search suggestions. And that's just one example of how not all requests are treated equally. Another example is that in our success rate metric, which we were tracking previously, we counted not only requests that impact pinners, but also requests that were used for our own infrastructure. So that meant logging events and events that we used to activate experiments and things like that, which pinners don't care about at all. Another reason that success rate doesn't always mirror user experience well is because of user behavior itself. Users respond differently to different types of errors, and we did a big in-depth analysis through our error logs to try to understand how users respond to errors. And we did find that users respond differently to persistent versus transient errors, meaning that if someone continually tries to access a certain product or makes some sort of request and they keep getting a failure, they're going to get frustrated with the site and leave it a lot sooner than if someone just can retry and it's like got some likelihood of being a success. And we hypothesized that a lot of the reason for this is that the internet and people's Wi-Fi is actually has lower availability than Pinterest itself, meaning that if a user experiences a failure, they're a lot more likely to think that it's them than us. And so they'll retry. Retries in themselves also bias success rate because success rate's account-based metric. So if I'm retrying and I keep getting failures, success rate's going to start biasing towards me because I'm just keep sending requests. Lastly, users tend to switch surfaces sometimes. If they aren't able to use Pinterest home feed, they might switch to search. And if they aren't, able to use search, maybe they switch to home feed. And success rate somewhat captures this in counting the requests from different surfaces, but it doesn't capture how long users spend unsuccessfully trying to use a surface before they switch. And so all in all, success rate is a useful metric, but it doesn't necessarily represent the user's experience as well as it could. So user uptime, we evaluated a lot of possible availability metrics that we could use as this new top line metric that we report to leadership and then also use during incidents. And we came across user uptime. So I'd highly recommend listening to this presentation. It's by Google on their paper. And it explains the metric a lot more in depth and how they came about it. But sort of the key insight is that user events are similar to probes into the system that can assess its health from that user's perspective. So sort of based on user events, we can tell at any given point whether the user is having a good time on Pinterest or not, and whether they're happy with the site and they're considered up. So the basic idea is that if a user has a successful experience, they're considered up until they have a failed experience or an unsuccessful experience, at which they're considered down. And they do that and they're down until they have a successful experience. And in this way, we can sort of create a timeline for each user that's segmented into these uptime and downtime segments. Based on this, we can basically just add up uptime and downtime for each user and then average over all the users' timelines to come up with an overall site uptime percentage. And in that way, we can treat each user equally despite how many requests they're making. I think the user 2 example here is pretty interesting to sort of illustrate the difference between uptime and success rate. So for this particular user, they only made 3 requests and 2 out of 3 of them were successful, meaning that their SR is actually around 67%. But they actually spent 3 time units, so we can say seconds, just on a failed experience, being frustrated with Pinterest. And they only had 1 second of uptime or successful experience. And so their uptime percentage was actually much lower and was around 25%. So in this case, the user actually had a much worse experience than success rate is representing. So Pinterest wanted to take a stab at implementing user uptime. And so for our MVP, we focused on our server only. So on that core API that I work on, we focus on that piece. It's a REST API. So one of the first questions we had to answer is what counts as a success and what counts as a failure? And it turns out that this is a really difficult question to answer. And it involves a big coordination between product, between leadership and between SRE. And, we had to really look into our product and identify what are the critical pinner experiences that we want to count in this metric. And what things do we think that are so fundamental to the product that if those things fail, it's a completely unusable experience for the pinner. And so what we ended up doing is breaking down the product by criticality. So we have 3 levels of criticality in our product, the top one being critical. And we implemented a classification system for our API endpoints, depending on what product flows the APIs would power. And we basically classified them, by endpoint criticality. And so this is just like a code snippet of what that looks like. So this is all codified. And based on this, we would only count user events to these endpoints. Another thing we've sort of had to think about, and we haven't been able to reason about perfectly yet, is degraded product quality. So for example, if users making a request to our home feed endpoint and they only get 1 home feed, they only have 1 pin on their home feed, that's a pretty poor experience, but technically it's a success. So, at what bad product level do we start counting it as a failure? And that's definitely something that we're still thinking about and that we haven't been able to account for perfectly yet. And so it's definitely a work in progress. So on the more practical side, what is the technology stack that we're using? So like I said, for our MVP, we focus on our Pinner API, and this is a Python REST API. It's a Flask server. So we have middleware layers, and in the logging middleware on the response, we log a really simple payload to a Kafka topic, a dedicated Kafka topic for our user uptime project. And just has 5 entries: user ID, session ID, the endpoint, a Boolean for whether it was a success or not, and then a timestamp. This Kafka topic is then consumed by a Flink job. So Pinterest, our Flink job is, our Flink framework is called, we call it Xenon. It's our stream processing platform. And this Flink job has 3 sort of steps, if you're familiar with Flink. Basically, the Kafka topic is ingested by the Flink job, and each event is windowed by user ID, meaning that there is one window or window of events for every user. So we have n number of windows, where n is the number of active users at any given time. And we keep windowing these events into, we keep inserting these events into different windows until a window reaches a certain size, or no events have been added in a certain amount of time, at which point we consider sort of the user session ended, and we consider that user no longer active on the site. And at that point, we evaluate the window, meaning that we sort of sort all the events by timestamp, and then, like that timeline that I showed earlier, it's just simple subtraction as to calculating sort of the uptime and downtime counts of time, milliseconds. And after that, that evaluation window then drains the metrics into several metric aggregation layers, which are then exported to OpenTSDB for consumption by whatever sort of infrastructure, scripts, etc. we want to use. One thing to note about this infra is that this is sort of the real-time implementation of user uptime, but it does have some delay given the fact that we need to wait for a certain number of user events to accumulate before evaluating the window and exporting these metrics. So there is about a 5 to 10 minute delay for this metric. So it's not perfectly real-time, because obviously we need to compare every event to the event before it to calculate the uptime or downtime count. So beyond MVP, there's a lot of things that can go wrong for a user aside from just the server on the client side. And so this includes things like mobile crashes. So one of the things that we found was that app crash logs are delayed until after app restart. So that's one challenge and sort of a built-in delay in what we can account for in this metric. On the other side of the house, there's web rendering. So error boundaries, we use React at Pinterest. So what level of error boundary are we counting as a failed experience? Is it just the page level error boundaries? Is it certain critical components? This is definitely something that's very much a work in progress for us. Right now, we're just counting page level error boundaries as failed events, because we consider that to be a completely unusable experience for the user. But that's definitely something that we are thinking about extending in the future if we identify certain components on the page as fundamental to the product. Traffic infrastructure is another very interesting thing. So really tracking anything outside of our ingress, we have a lot less visibility into. So Pinterest doesn't have in-house traffic infra or DNS, CDN, GSLB. These are third-party infra that we use. And when we're calculating user uptime, we really only want to count failed experiences where Pinterest is at fault. However, for these third-party infras that Pinterest is then configuring, it can be difficult to distinguish between the two, because our CDN might be having an outage that might be due to the CDN itself, or it might be due to the fact that we misconfigured it. So what ends up happening is we sort of have a ton of logs, and then we end up having to sort of manually manipulate depending if certain outages happen. And we need to treat those errors differently depending on the outage to make sure that the metric is meaningful for Pinterest. So the current implementation is that we have an offline report available after a 1-day delay when all of these logs become available in our tables. Like I said earlier, we use this metric to report to leadership. And so we actually have a monthly availability report that we report and that SRE is responsible for. And this does require manual manipulation to account for, error codes that haven't yet been integrated. So sometimes we'll have an outage and we'll say, wow, we're not counting this, but we should be. So we need to sort of manually account for that in our monthly report. And then outages related to misconfigured third-party infra, those are things that we need to manually account for. Another sort of interesting case is a loss in uptime. So these are pretty severe outages where we actually have a big drop in engagement or active users. And right now, if a user becomes inactive, we don't count them at all in uptime. After a certain amount of time, they're just not on the site. They don't think one way or another about Pinterest, so we don't count them as up or down. However, if we have a big outage and a lot of people leave the site because they're unhappy with Pinterest, not counting any part of that as downtime is largely inaccurate because it's just represented as sort of an absolute loss in uptime, but not necessarily a corresponding increase in downtime. So sometimes we need to manually account for that loss of uptime if we do have some severe outages. So what's sort of next on the roadmap for us? There's a lot of work still to be done at Pinterest with respect to user uptime. One of the things that we are working on and somewhat completed recently is incident integration in our guidelines. We reclassified previous incidents. So we sort of went back in logs and we looked at incidents of various severities and identified how much downtime was caused by each of those incidents. Based on that, we were able to sort of draw lines in the sand for where the cutoffs are in amount of downtime for various incident severities. And so we use those guidelines in conjunction with existing guidelines to make sure that we're accounting for user experience in how we triage incidents and with what urgency we address them with. One sort of case where this comes into becomes very handy is incidents where there's not a big number of errors, but it lasts a long time and the errors are very poor user experiences. Because over time, these errors and downtime accumulate and can accumulate to actually be a very severe incident. But because there's never any huge increase in error, a big drop in success rate, sometimes we weren't treating them with the urgency that they should be. So this gives us leverage to sort of say, we need to deal with this now before it becomes worse. Back to sort of the development side, we definitely have a lot of work to do on our clients to better understand user experience. I had mentioned mobile earlier. Turns out that there's a ton of different mobile response codes that they can get when trying to talk to our API. And each one of those has a different meaning, and we're still trying to figure out exactly what they all mean and which ones we should count. And sometimes we need to count them and sometimes we don't, depending on what the outage is or what the situation is. So that's definitely something that we're still fine-tuning as we go along. I mentioned defining our product by criticality standards. So we're actually in works of defining a contract between SRE and product in terms of those 3 levels of criticality and what the uptime or availability guarantees are for those various product flows. And so for those specific endpoints, we can set different expectations for sort of what the SLOs are. We can also use user uptime information to identify what the highest ROI projects are. So we've used user uptime to find really user impacting bugs that weren't happening at any high frequency, but did cause bad user experiences and were really easy to fix. And it's also helping us identify other bigger efforts that can help, make a stepwise improvement in user experience. For example, getting rid of all the steady state errors would be a big improvement for users. We're also looking at extending user uptime to non-organic products. So this would be our ads and partners products, which we do not currently have on the uptime paradigm. And also the on-auth experience. So I mentioned that we window by user ID. This means that we don't count events from unauthenticated users. However, the on-auth experience, particularly on web, is really important for the growth of the website, for signups, for logins, etc. And so measuring uptime of that experience is very business critical, and it's definitely something that we want to do in the future and that we're actively looking into. Lastly, performance is a super interesting thing when it comes to uptime, because a video can take 10 seconds to load, and technically it's a success, but from the user experience perspective, that might be a terrible experience and it might be considered a failure on our part. So how slow is too slow? And then how do we mark those sort of responses as failures and then log them into our system and override whatever success we had previously recorded for that request? So sort of taking a look at how long it takes media to load, how long it takes our feeds to load, et cetera, and then understanding and then trying to make some decisions and working with product to identify what are the thresholds for what counts as a failure. So in summary, working on user uptime has been really interesting and a very fun experience. And we've learned a lot about our product. We've learned that it's really difficult to classify what failed means for a user. And whatever classification system we use is almost certainly going to be imperfect and always going to be a work in progress, especially as our product evolves. At Pinterest, user uptime has become a really critical tool for understanding how outages impact pinners. However, this is in conjunction with the success rate. So although success rate is not perfect for understanding user experience, it's still a very useful metric and does give a very holistic picture into server health. And so these are two tools that we use together to classify incidents, understand the health of the system. And success rate is still the primary SLI that we use for our error budgets. We use a success rate metric for almost all of our systems. We have found that it's not yet possible to take manual intervention completely out of the uptime calculations that we report. We can get a pretty good estimation through that automated offline report that I mentioned and through our real-time metric. However, there are still cases where a certain outage happens or a new product flow is introduced, and we need to sort of go back and account for that situation in various ways, whether that's counting a certain class of errors is up or down instead of what we were treating them previously, or whatever that is. We sometimes need to go back in and do some tinkering with our data. We discovered a new class of client-side failure types that contribute really to the majority of downtime. We found that on average, our server causes about 10 days of downtime per day, for all the users of Pinterest, but our clients actually cause 3 or 4x that. And so we have a lot more insight into things that happen within our infra, but then outside of our ingress, it becomes a lot more nebulous in terms of tracking errors, understanding exactly what were the environment variables that cause some sort of bug, repro. It becomes a lot more difficult outside of ingress. And so this is this new class of failure types that we weren't really looking into very closely before, and now it's going to definitely be something that we focus our efforts on, because we know that we have a lot more leverage there to improve user experience. And then lastly, one of the biggest benefits of user uptime is that it's made it much more simple to communicate impact. Before, when we had an outage or we're trying to get some fix prioritized, we would say it's causing X number of errors, success rate is at this percentage, but we weren't able to really tie that to business, the business metrics to user experience. And Pinterest really wants to put pinners first, and that's, one of our core values. And so being able to take, server language and, code and, things that we try to explain using code and infrastructure language, and take that terminology and translate it to, this is a bad user experience, and this is how much time that users are spending on failed Pinterest because of this problem, makes it easier to communicate that impact and get it prioritized. So yeah, thank you all for listening to my presentation. Feel free to reach out if you have any questions, either at amukherjee@pinterest.com or on Slack after the presentation. Enjoy the rest of your conference.